Hi, the next we want to discuss a typical problem in binary classification problem. So suppose that observations are separable by a hyperplane in the feature space. So this is feature space Rm, but now example is m is equal to 2. So we have two clusters, the blue one and the purple one. And this is easily separated by a straight line, for example, this line. But this line is not unique. This line also perfectly separates two groups, and this line also. So this problem happens typically in logistic regression. Because logistic regression has linear boundary. So logistic regression basically think about the signed distance to specific direction. For example, we estimate the probability that observation falls in the blue class by this kind of logistic curve. So this is basically the probability of blue. So support vector machine avoid this problem by setting different the classification rule. So the idea of support vector machine is to make the margin largest. Okay, so blue class and purple class are separable, and the line separating these two classes are not unique. But we want to, at the same time, maximize this margin. So basically, we want to maximize the smallest distance from observation and the separating hyperplane. So in this way, that we can minimize test errors, because if we have more observations in test set, then some observation may be here. And some observation in purple class may be here. Even for test set, we expect the error size is small for support vector machine. One problem in support vector machine is sometimes the question is not entirely separable. This case on the left pane, so this is separable case because this straight line perfectly separate blue group and purple group. But right hand side is non-separable. Because even if we put best line we can do, still that we have some errors. So this is the purple side and this is blue side, but this one is an error, and also this one is in an error. So the support vector machine is, if it's not separable, allow the certain percentage of errors. In that way, it can work for any data sets for binary classification. Okay, so now that you can solve question 3.26.2 in Canvas.